Alright guys, good evening. Guys, good evening. I'm here for a asynchronous lesson on Waveguide. Okay, so let me, I need a blank wall board. Okay, so I'll be using the PowerPoint. Yeah. Okay, let me see. I have enough slides. Dagdagan pa natin para masaya. Okay, we can have our slides. Okay, so we have pointer, pen. Okay, okay. Hi, it's me, your friendly friend. Bahala kayo kung ilalagay niyo yan. Neighborhood Spider-Man. Now, our topic is about waveguide. Okay, say cursor ko. Kita cursor ko. Waveguide. Alam natin na as we increase or as we get the operating frequency is getting higher, let's say 1 gigahertz above, okay, let's consider your micro, nagbabago na rin ang transmission line. Kasi below 1 gigahertz, okay, the coax is, the transmission line is a coax, okay, coaxial, and sometimes we have your flat wire, no? Maraming tawag ang coax, no? Sometimes we call it shielded, or I would say dito shielded twisted pair. Yan. Tapos dito sa coax, well, usually both are named as cable. So nagkakatal siya sa impedance. This is 75 ohms. Characteristic impedance. This is 300. Now, we are here in Waveguide. We'll be using a rectangular tube. No? It's a tube, hollow tube, maybe made of brass or copper. Yan. Mayaman kayo, di mag-gold kayo. Yan. Tapos, dito yung principle ng fiber optics ganun din. No? So, you have your wave, electromagnetic wave being entering here. At magbabounce na lang yan hanggang makarating sa paraloonan. So under this waveguide, there are 2, 4, 6, 8 topics. We're going to, this will be the outline of our asynchronous lessons, no? To be able to understand and discover the structure, okay, of rectangular waveguide. And then, of course, we have the modes. Ito yung mga parameters para makita natin kung ito ay feasible or not. The modes. We have 2 types of modes. Later, I'm going to discuss it one by one. Then the condition, okay, for your waveguide propagation. Waveguide propagation. Okay. Okay, especially in rectangular waveguide. Okay. Another one, of course, until when? What's the limitation? Or we call it now cut off. So hindi porke 1 gigahertz above. No, so of course, you have to, there is a certain limit, or else no, the signal will not passing through and will not go to the destinations. So we call it cut-off frequency, where as I'm asking, we call it cut-off frequency, no? FCO, or sometimes we call it cut-off wavelength, lambda CO, course of rectangular waveguide. Then another one, same cursor. Come on, cursor. And another one, the checking of modes in rectangular waveguide. Then two for and then number 6 we have the intrinsic the intrinsicity of wave Z impedance of rectangular waveguide. Then also there is a parameter for phase velocity and group velocity of rectangular waveguide. And finally, the guide wavelength. No? The guide wavelength. uh, of rectangular waveguide. So structure, modes, conditions for waveguide to propagate, then until what's the cutoff, the limitations in terms of frequency and in terms of wavelength. Of course, they're interrelated. Then we're going to check the modes in rectangular as well as in circular. Then intrinsic, siyempre transmission line niya, may impedance yan. Okay. And then we have the phase velocity and the group velocity and the guide wavelength. Okay. So we'll start with structure. Okay. Of our rectangular waveguide. Okay. So, ito na makita yung cursor. Ayan. So this is your rectangular waveguide. Ayan. So this is your B. Ito yung ating B. Ito yung ating A. Ayan. Okay. Sometimes B also connotes as N subscript or M in A. Ito naman M in A. Okay. So setting height, ito yung depth, yung base. And of course, na-tube yan eh. For a certain unit length. Okay. And okay. So infinite, no? Or so this is an infinite perfect conductor. No? So this is an infinite perfect conductor. Perfect conductor. Ayan. Okay, this also follows the XYZ axis. No? Kasi alam naman natin, na tatlo ang component ng electromagnetic wave, di ba? Okay, so this is your X. Sometimes we call it your magnetic component, the electric component, Y in transverse. And then this is your directions, your Z. Okay? X. Okay. Or vice versa. X can be your electric field, Y can be your magnetic field, and Z direction as long it is a three component for electromagnetic wave. And then there are conditions, of course. It is standard that we have to maintain these conditions, or else this benchmark will tell us if the mode is enough, or until when you're going to operate the waveguide in terms of modes. Okay? So the conditions to be followed for wave propagation. So pag hindi natin na satisfy ang ating propagation. Okay? So definitely hindi siya feasible. Okay, so lambda C must be greater than the operating wavelength. So the cutoff. So this is your cutoff wavelength. Okay. This is your cutoff wavelength. Okay. Wavelength. And then must be greater than your operating wavelength. Wavelength. Okay. In terms of frequency, the cutoff frequency must be less than the operating frequency. Okay? Okay. So the mode, okay. So okay. So the mode of your, okay, bago tayo pumunta ng mode, okay, in cutoff frequency, and cutoff wavelength versus the cutoff wavelength. Okay. Yan. Okay. It is for sure that the cutoff wavelength for the experiment is 2b 2ab over the square root of m square b square plus n square a square at, for sure, at TE 10. You see what happened, no? So ito ang M, ito ang N. So M mo 1, magiging 1 yan. Ito magiging 0. So magkakaroon ka ng B. So mawawala na to, diba? So meron ka ditong square root of B square, which is B, cancel ang B. Kaya nga, the cutoff of wavelength is equal to 2A. Okay. Yan. Isang formula. And then in terms of frequency, okay, FC is equal to C over 2 multiply the square root of M square over A square plus N square over B square. Okay. Ayan. So at TE 10, your FC is C over 2E. See, this will be the correlations of cutoff. Okay. So let me go now how these modes are being created, formulated. No? So let me label first. So if we have a TE mode, in fact there are two types of mode. TE mode, transverse electric, and transverse magnetic mode. So pag transverse electric, it deals with voltage. No? It based on voltage. Okay? This is based on voltage. Voltage. On transverse magnetic, based on current. On current. So TE stands for transverse electric. Ayan. And TM is transverse magnetic. Ayan. And transverse is perpendicular. If you're going to define transverse is perpendicular. Okay. Now, it is also experimented that TEM, transverse electric mode, does not allow for rectangular waveguide. We will see later. And then, so basically, a TE, okay, a TE MN, MN, or TM MN. So, alam, this is your A, and this is your B. Ito yung sukat na waveguide, tama. Ito yung B, ito yung A. Sometimes this is your N. Wala. Pang cursor. Ayan. This is your N, this is your M. Okay? Ayan. And it is also correct that TE10 is the dominant mode. Dominant mode. Okay? Where A, M is 1, and N or B is 0. Let me generalize first. Now, it is also find out that you can check these things now. The the rectangular waveguide. Okay, so if you have a series of mode, now let's say TM10, TM01, TM11. Okay, so we have also TM21. Okay, so you can choose now 1, 2, and TM22. Wala. 22, so on and so forth. Okay, compare to your cursor. Where is my cursor? What cursor? Ayan. Versus the TE10. Then we have the TE01. Then TE11. And then TE21. Then you have your TE12, TE22, so on and so forth. Okay? Now, you will notice that in rectangular waveguide, these are not allowed. Okay? These are not allowed. And this is sometimes called through the experiment of Evans-Cent mode. Okay? And sometimes the dominant mode is from this until here. That will be your dominant mode. Okay? And then later you will see now why the TM10 and TM01 is not uh, being used. Okay. Okay. So another one is the intrinsic. No? So this will follow your a guide of your lambda c is greater than lambda cut of lambda and or the cutoff frequency is less than the operating frequency. Okay. All right. Let's continue. Now, how about the intrinsic? Pabalikan natin ito. The intrinsic wave characteristic impedance of the rectangular waveguide. So the okay, I don't know what this Greek letter TE. Okay, is equal to 120 pi over the square root of your 1 multiply the FC over F sub square, which is equivalent to 120 pi over cosine theta. Pakihanap na lang ano nito, ano ang sabihin niya. Or we could have this one for the TM will be equal to 125 square root of 1 minus the quantity of FC over F sub O square, which is also equivalent to 125 cosine theta. Okay? Kaya nga, for a phase and group velocity, okay, for a phase and group velocity, no, BP and group velocity, VG. So BP must be equal to C over the square root 1 minus FC over F sub O square, equivalent to C over the square root of, in terms of wavelength, 1 minus cut of wavelength over operating wavelength over cut of wavelength square. Now in terms of group velocity, so we have Vg is equal to C multiplied by the square root of 1 minus L sub C over F sub O square is also equivalent to C square root of 1 minus the quantity lambda O and the cut of wavelength square. So the correlations is B P BG is equal to C square. And we could say that the guide wavelength, which is this one, is equal to lambda O over the square root of 1 minus lambda O over lambda C square. Okay. So these are the formula. Now let us now see their modes in a different analogy, because in electronics we need some hypothetical way of interpreting them. Okay, especially in terms of rectangular waveguide mode. Okay, let's start with TE. With TE mode. So as we all know, the TE mode is based from voltage. Okay, so if this is your rectangular waveguide, ito yung rectangular waveguide mo. Ayan. At meron kang kasi ganito ang takbo ng ano mo ng iyong mga wave sa loob. Okay, so meron kang 4. Okay. And then transversion. So ano sila? Meron sila perpendicularity. Ayan. So this is your A. Okay. This is your A. A yan Simula dyan, yan. So, A is your M, okay, equal to 1. Okay. And then, this is your B. Cursor, yun. If this is your B, so your B is N is equal to 1 as well. Equal sila, no? Pwedeng tig-5, tig-2. So this is in what mode? So we could say that this is a TE11 mode. TE11 mode. Okay. Now let's try this one. Yan. So let's say you have this 3. So meron kong 1, no? Isa lang yung bilang yan. Tapos here meron kang dalawang pares. Yan. So this is your A, on which your A is M is equal to 2. Dalawang grupo yan eh. Yan, isa, dalawa. Ito isa lang to. This is your P, your N is equal to 1. So this is now your TE, TE 2, M, N 1, TE 1, 2, 1, TE 2, 1. Okay. Now if you have, how about a TE 20 or 03? Okay. So, how about the TE03? Okay, so wala kang pataas, no? Puro paa lang. So, tatlo. This is your 1. This is your another one. Then this is your third one. Ayan. So, your A here is equal to M is equal to 0. And this is your B, your N is equal to 3. Okay? So, we have, that is your TE. No? Ganyan nangyayari sa loob ng waveguide actually. Then let's one another one. How about 30? TE30. So, kabaliktad naman nito. Ayan. So, this is 1. This is your second. This is your third. So, your A is equal to M, which is 3. And then your B is N is equal to 0. Ayan, this is a TE transverse electric 3-0. Okay? Ayan. What is now for a transverse magnetic? Ayan, dito natin makikita na yung TM10 and TM01 is not visible. Transverse magnetic, in which current is our based from the current. If this is your waveguide and you have only one common, let's say, point or source ng ng frequency or ng magnetic wave or TM, okay? So, mapapansin mo, ang A mo, meron kang isa. This is your M. Tapos may isa ka rito sa B, and is equal to 1. Kaya meron kang TM11. Okay. kung you make 3 points here as well as here, connecting them, connect mo yan, tsaka ito, papansin mo, ang A mo, on which M is equal to 2. And then your B, your N is equal to 3. So this is your TM, transverse magnetic 2, 3. No? 2, 3. Kaya imposible itong ano yan. Yung TM, kita mo 1, 0. Okay? Mahirap i-explain. No? Using this, yung Evans cent, no? TM 1, 0 and TM 0, 1. Okay? So they are not possible. Not possible. This kind of mode in rectangular waveguide. Okay? So we can conclude as well that the dominant mode TE10, okay, which is A can be also equal to B, so we have TE10 and TE01. Okay? Yung mga TE na 4, 3 and TE 3, 4, these are, call it degenerate mode. They call it degenerate mode. Ayan. Okay. So their cutoff frequency are the same. Ito siya, TE34 and TE40. Okay. So isang characteristic nila, kasi yung course short ko. Okay. Their cutoff frequency are the same. Okay. Okay. Let's have examples. Okay. Examples. Okay. Example tayo. Problem number 1. The dimension of a waveguide are 2.5 centimeter by 1 centimeter. The frequency is 8.6 gigahertz. Find the following. Ganda na sulat ko, no? The possible mode. B, the cutoff frequency. And then C, the guide wavelength. Lambda G, the guide wavelength. Okay. Hanggang na kagad natin ng given. Next ano na tayo. Solutions. Where are you, cursor? Solutions. Okay. First, given muna tayo. Yung A natin is 2.5 centimeter. Yung B mo 1 centimeter. And ang operating frequency is 8.6 giga. Okay. Now the operating lambda, okay, is C over operating frequency. Speed of light 3 times 10 to the 8 over 8.6 times 10 to the 8 to the 6 rather. So this is around 3.488 centimeter. Kindly double check it out. That is your operating lambda. Okay? Diba may condition tayo? Conditions. Condition natin is para sa propagation. Kung hindi sa satisfy, so hindi sa feasible. Kasi marami tayong series of modes. Yan. Versus the FC, the cutoff frequency must be less than the cutoff operating frequency. Okay. Tapos, meron tayong formula pa rin. Pwede mo sunod. Ayan. That lambda C is equal to 2A, 2AB over the square root of M square, B square, plus N square, A square. And here, sa kabila naman, the cut-off frequency is C over 2. Multiply the square root of M over A square plus N over B square. Ayan. And then, from the series of, okay, next. And then, alam natin, yung TE sa TM and sa rectangular waveguide, nagsisimula sa 1, 1, TM 2, 1, TM 1, 2, and maybe good up to TM 2, 2. So on and so forth. Ang dominant mode ay nagsisimula sa TE in terms of transverse electric 1, 0. We have TE 0, 1. Okay, T ito, no? TE 0, 1. And then we have TE 1, 1. TE 2, 1. TE 1, 2. And TE 2, 2. So hanggang saan ang limitasyon? Okay? Start tayo sa TE10. Simula tayo sa TE10. Okay? So this is equivalent to 2A. Diba? So this is 2 multiplied by 2.5. And ang given kanina, centimeter. Centimeter yan is equal to 5 centimeter. And 5 centimeter is greater than the lambda 0 or ito yung cut-off pala, no? So the cut-off wavelength cursor, hindi kita makita. So the cut-off wavelength in TE10 is 5 centimeter, which is greater than lambda ating ano natin, that if this is your cutoff, the cutoff is greater than, ayan, so feasible. Okay, ito, okay, ayan, so TE10 is feasible, TE10 is possible. Okay, how about the TE01? TE01 mode. Okay, so TE01, so the cutoff wavelength for TE01, okay, for TE cutoff wavelength for TE01 is 2B, 2B. Okay, so balikan mo yan, magiging 2B yan eh, no? Pag binalikan mo to, itong formula na to, ay hindi yan, ito, sa baba, magiging 2B yan. Okay, so ano yung B? 1, so meron kang 2 cm. Okay, so 2 times 1 cm, so we have 2 cm. 2 cm is less than the um, the operating wavelength. So kung ganon, hindi siya feasible. So we could say na hindi magpo-flow ang signal. Okay, so TE01 mode is not possible. Okay, so how about your TE? So tuloy nyo to, assignment nyo. What is TE11? Is it feasible or not? Okay, yan. Okay, so TE11, no? Okay. And the next is the cutoff frequency. Solving for the cutoff frequency. Number 2. Cutoff frequency. Okay. For TE10, kasi hanggang saan lang. So the cutoff frequency for TE10 is C over the wavelength of TE10. So meron kang 3 times 10 to the speed of light over so 5, no? 5 centimeter. So if you have a 5 centimeter, so for short po, hindi makita. 5 centimeter, so meron kang 6 gigahertz. Okay? Okay. So yun yung ating cutoff frequency. Hanggang dyan lang ang kanyang operating frequency. And then, your letter C, so the guide wavelength will be this one, is lambda O, the square root of 1 minus lambda O over cutoff wavelength square. So meron kang 4.86 centimeter. Okay. Right. Let's have another one. Let's have this problem. In this problem, we is introducing another parameter, the permittivity. So, a rectangular waveguide filled with a dielectric material. Dielectric material. Yeah, the electric material of a relative permittivity. Epsilon of 4 has a inside dimension, has the inside dimension of 3 by 1.2. 3 by 1.2 centimeter. Okay. Square. So the cutoff frequency, complete with the cutoff frequency for the dominant mode. For the dominant mode. And so given cursor, asa ka na cursor? Yun. This is the permittivity. This is 4. A is 3. Your V is 1.2 centimeter. Okay. And the dominant mode, TE10. TE10. Okay. Your M is ano tayo? Dali ah. Your M is equal to 1. Wala ating pointer. This is your M is equal to 1 and this is your N. Okay? And the formula for the cutoff frequency, S sub C is U over 2. Actually, this is velocity to. And ipagka-V yan eh. Okay? Parang ganito. Yan. over 2 is equal to the square root of m over a square plus n over a over b sorry square. So we have 3 times 10 to the 8 over so this is the square root of permittivity multiplied by 2 at into, no? And then multiply the square root of 1 over 3 times 10 to negative 2 3 centimeter okay 2 square plus 0 so negative 2, no, power of negative 2 centimeter okay, and then so FC is 2.5 gigahertz okay. So this is the velocity of light in the presence of the electric permittivity or the relative, no, of the electric material. Ito is your velocity of light in the presence of permittivity. That's the electric. Okay? So 2.5. Okay. Ang sagot. Ito ang sagot. Yan. For dominant mode of 1.0. 1.0. Okay? Alright. So your second assignment, ito yung pangalawang assignment nga natin, no? Kanina yung kanina. Yun, ito yung second assignment. Ito yung una, this is visible or not, no? Tuloy nyo lang yan. And then, the second one is this. Okay. The cutoff frequency of the dominant mode of a rectangular waveguide having an aspect ratio more than 2 is 10 gigahertz. Okay. The inner broad wall dimension is given by blank. Yan. Okay? So that is number 2. Okay? All right. Okay, that's it for our waveguide. Then our unit test will be on Holy Tuesday. Okay, so always remember that we are created according to the, the image of God. So we are not created na parati ka nakasimangot, no? Although we are normal, but we are created to go back to the, by saying sorry. At nakita ko rin na dito sa katatapos na one day of defense ng ladder nakita ko na mahalaga pala, no, yung hindi mo kaya, kailangan mo ng tropa, kailangan mo ng ibang grupo to collaborate, because that is really how we are created, to become a collaborative part of other people. Their success will also depend, your success will also depend on how you collaborate, because that is the original plan of God. So we have to start bringing people closer to Him. Okay, with this, good night and thank you for listening. God bless you all.